Let's start 3-4, solving equations with variables on both sides. So until now, we've had a variable with some extra terms, and it always equaled a number on the other side. Now we're going to have terms over here, some with an x, and then an x on the other side too with some extra terms. So it's a little more complicated, but it also gives you as a mathematician more choice. So let's start. Here's the basic steps. You need to collect the variables. How you do that, again, you're going to have some choice in that. There's a strategy I use, but you might be able to find something that works for you, and it might be different. The second thing is the other thing. Usually that'll be adding or subtracting, but not always. Then you'll do the variable thing, the thing attached directly to the variable, and that's usually the multiplication or the division. Okay, usually, it's not always. Here's our first example, example 1a. 3a equals 2a plus 3. According to our steps, we need to collect the variables. So that's what we're going to do. We're going to collect. I have a 3a and I have a 2a. Those are like terms, but they're separated by that equal sign. So in order to collect them, I have a choice. Should I move the 3a to the right side, or should I move the 2a to the left side? My strategy is I look at which one is bigger, and I want to keep everything as positive as possible to avoid those negatives. So I'm going to move 2a. 2a is a positive, it's a plus 2a. The inverse is a negative 2a. So I'm going to subtract 2a from both sides. 3a minus 2a is 1a, or just a. Here's my equal sign, it comes straight down. 2a minus 2a, it goes away. And then 3 is what's left over. So my answer for this example 1a is a equals 3. Let's try a harder one now. This is example 1b. 3v minus 8 equals 7 plus 8v. I have a variable here, and I have a variable there. Those are like terms. I have a choice. Should I move the 8v to the left or the 3v to the right? In order to keep it positive, I'm going to move the smaller one. So I'm going to say this positive 3v, inverse negative 3v, and I'm going to move that to the right-hand side. 3v minus 3v goes away. I'm left with negative 8 on the left-hand side equals 7. Now I have 8v. This shouldn't have that right. Oops. Let's get rid of that. That's a 8v minus a 3v. 8v minus 3v is 5v. Okay, and this is what we were doing before. So should I do the 7 or the 5v? Here's where we do the other thing. So this is a positive 7. Let's do the inverse and let's subtract 7 from both sides. Negative 8 minus 7 is a negative 15 equals 7 minus 7 goes away equals 5v. Now I get to do the variable thing. I see multiplication. The inverse is division. Let's divide. And I have v equals, right, because this became 1, negative 15 divided by 5 is a negative 3. So at the end, my answer is negative 3 equals v. If you did it in a different order, if you moved this positive 8 first, you would get the answer v equals negative 3. You'll always get the same answer. Okay, it'll just be flip-flopped where the variable is on the left or the right. Here's C. G plus 7 equals G minus 3. I have a G here and I have a G here, and they both have a variable coefficient of 1. So it doesn't matter which one I move. Let's say I move the one on the left to the right. What is G minus G? Well, 0. 7 equals G minus G, 0, negative 3. Does 7 ever equal negative 3? Answer, no. So the answer is no solution. It's impossible. You can't have 7 and -3 at the same time. It doesn't make any sense. So if your variables completely disappear, that's your answer, no solution. Example 2a, this one's way more complicated. 10z minus 15 minus 4z equals 8 minus 2z minus 15. Okay, before I collect and move all of the variables together, I'm going to combine these two like terms first. They're on the same side of the equal sign, so I can combine them now. They're like terms. So 10z minus 4z gives me 6z, and then minus 15 equals 8 minus 2z minus 15. Okay, I have a constant and I have another constant here. So I'm going to simplify those next. 6z minus 15 equals 8 minus 15, that's a -7, minus 2z. Okay, now I only have one variable term on both sides. So again, which direction should I move? This one is negative, so I'm definitely moving this one to make it positive. Let's add 2z to both sides. 6z plus 2z gives me 8z minus 15 equals, this goes away, -7. Other thing first, let's add 15 to both sides. This goes away. 8z equals -7 plus 15 is 8. You divide it by 8. Oh, I'm running out of space. Becomes 1. Z equals 1. So it started out so complicated, and your final answer is z equals 1. That's why I love simplifying these types of equations. Okay, one more. 2c plus 4 minus 3c. So already off the bat, I have like terms on the same side. Equals -9 plus c plus 5. I see two constants that can be combined. So let's do both of those steps at the same time. 2c minus 3c, that's a -1c plus 4 equals -9 plus 5 is a -4 plus c. This one's negative, so I'm going to do this next. Let's add 1c to both sides. And I get 4 equals -4 plus c, that's like a 1 right here, so 1c plus 1c is 2c. Other thing first, let's add 4. 8 equals, goodbye, 2c, divide it by 2, do the inverse of multiplication, and 4 equals c. And that's your answer. Okay, told you that was the last one. I know this one was long, guys, sorry. Here is your turn. So in 3-4, please do number 2, number 4, number 6, and number 7. Bring your paper to class tomorrow with all of the work. Just submit the answers in the Google form. So your answer would be c equals 4 or 4 equals c. Z equals 1. Okay, so your answers are very short, but bring your paper tomorrow in class. I want to take a look at it. All right, good luck, and I will see you tomorrow. Thanks, guys. Bye.